Andrew Hoell, and I work for the NOAA Physical Sciences Laboratory, where I've been for the past 5 years. Since 1980, the United States has sustained 285 weather and climate disasters that each exceeded $1 billion in direct economic losses. The total cost of these 285 events exceeded $1.8 trillion. 33 of these billion-dollar disasters were related to flooding, and 28 were related to drought. Here we explore how climate change may be related to costly floods and droughts in the United States. Shown in this image is a time series of billion-dollar flooding events over the United States compiled by the NOAA National Centers for Environmental Information. 33 billion-dollar flooding events occurred in the United States since 1980. Of the 33, 20, or nearly 2/3, occurred in the last 15 years. That means between 1980 and 2005, billion-dollar floods occurred on average once every other year, while between 2006 and 2020, a billion-dollar flood happened on average more than once per year. This image shows the location of billion-dollar flooding events since 2006. These flooding events predominantly occurred in the central and eastern United States. This includes areas in the northern Great Plains, the Midwest, and the Ohio and Tennessee river valleys. States along the Missouri and Mississippi rivers endured the most billion-dollar floods. These states include Iowa, Illinois, Missouri, Arkansas, and Louisiana. 2019 was a record year for flooding in the central United States. 3 different billion-dollar flooding disasters were identified, which combined led to more than $20 billion in economic losses. Shown in this image are the location of the $3 billion flooding disasters in 2019, alongside all other billion-dollar events during that year. These flooding events occurred along the Missouri, Mississippi, and Arkansas rivers in their tributaries during spring. The magnitude, extent, and cost of these floods motivated us to study what caused them and whether the causes were affected by climate change. The devastating floods in spring 2019 immediately followed America's wettest winter, which spanned December 2018 to February 2019. Precipitation percentile ranks for winter 2019 are shown for each county in the contiguous United States and Alaska. Greens and deep blues indicate more intense winter precipitation for a county. Exceptional precipitation was observed almost all of the United States, particularly in the central and eastern areas of the country, over watersheds that feed into the Missouri, Mississippi, Arkansas, Ohio, and Tennessee rivers. The exceptional precipitation saturated the land surface, and because temperatures in some areas were below freezing during the cold winter, copious amounts of snow and ice accumulated, ready to melt in spring and overwhelm rivers as temperatures increased. A time series of December to February precipitation departure from average over the lower 48 states reaffirms that winter 2019 was the wettest on record over the contiguous United States. The time series also indicates a statistically significant increasing trend in wintertime precipitation, and that many of America's wettest winters occurred in the last 30 years. The dark blue bars show American winters that fall into the wettest 10% of the historical record dating back to 1895. Since 1989, 5 such winters were observed, or 1 every 6 years. The prior 70 years, spanning 1920 to 1988, saw 6 such winters, or 1 every 12 years. That's a doubling of the frequency of wet winters in the past 30 years. Precipitation during wet winters like 2019 is delivered by individual storms. And during winter 2019, the central and eastern United States endured many more heavy precipitation events than average. This is indicated by the observed wintertime precipitation change between a recent 30-year period and a prior 60-year period, shown in the left-hand image. While a change in wintertime precipitation has been observed, it does not tell us definitively that this change is caused by humans. For this purpose, we use many climate model simulations in which the historical record of greenhouse gases are prescribed in the model and repeat the calculation performed on the observations. We find that the climate models also simulate a precipitation increase in the central United States, which provides evidence that the observed wintertime precipitation increases in the region are related to human causes. This also suggests that subsequent springtime flooding is related to human causes as well. Now, in summary, we find that heavy precipitation events are increasing over the United States, and that in particular for spring, this is leading to more springtime flooding, and this flooding is related to anthropogenic influences. While the central United States has experienced many billion-dollar flooding disasters since 2006, The western and southwestern United States has experienced many billion-dollar drought disasters in the same time span. The number of events are noted on a map that shows the number of billion-dollar disasters since 2006 related to drought. Drought has gripped the southwest United States for the better part of 2 decades. A time series of precipitation departure from average over the Southwest shows persistently low precipitation since 2000. The duration and magnitude of the low precipitation is impressive when considering a historical record that dates back to 1900. While precipitation is a key factor in drought, temperature plays an important role too. Warmer than average temperatures, as were observed over the past 2 decades in which precipitation was low over the southwest United States, can lead to many negative impacts related to water supply. These impacts include a stronger and faster evaporation from the land surface, which leaves soils drier and reservoirs lower. Another impact is that wintertime precipitation may fall in the form of rain instead of snow, which lowers water storage in the snowpack and lessens water availability later in the year. The human effects on the ongoing southwest United States drought are uncertain. Warm temperatures during the drought have been linked to human causes. However, precipitation during the drought has not been clearly linked to human causes, as studies have suggested that low precipitation is related to natural causes. Overall, this is an ongoing area of research and will continue to be studied for some time.